In this session, we dive into the essentials of Bitcoin security, the keys. We'll clarify the roles of public and private keys, their creation, management, and the significance of hierarchical deterministic HD wallets in ensuring a secure Bitcoin experience. Bitcoin employs a dual key system to secure transactions. The public key acts as a digital address for receiving Bitcoin, while the private key is a closely guarded secret that permits the spending of Bitcoin from your wallet. This lesson keeps it simple, avoiding deep technical dives into key formats. Consider this analogy. Liken your public key to an email address, which you distribute freely, and your private key to your email password, which remains private to secure your communications and control outgoing messages. Securing your Bitcoin fundamentally depends on the privacy of your private key. Exposure means potential loss, with limited recovery options. Imagine your private key as a complex code to a publicly accessible safe at a train station containing your valuables. Though the code is complex, if someone were to discover it, they could access and take your assets unnoticed. HD wallets use a single mnemonic code to create a series of key pairs, simplifying the generation, organization, and backup of multiple Bitcoin addresses. We'll explore mnemonic codes, also known as seeds or backup phrases, in more detail in a future lesson. To make the concept of hierarchical deterministic HD wallets more intuitive, let's use the analogy of a tree. Envision an HD wallet as such a tree, comprised of three primary components: the trunk, the branches, and the leaves. In this analogy, each leaf symbolizes a key. On one side of the leaf, you find the private key, while the opposite side bears the correlated public key. Your Bitcoin address is generated from the public address, so in this metaphor, you can consider each leaf as an address. Why do we need so many leaves? There are two main reasons. First, it allows you easily track the status of each address and associated transactions. For example, let's say you are asking 3 friends to pay you back in Satoshis after paying for their dinner. If you give everyone a unique address, you can easily track who sent you the funds and who hasn't. Secondly, it gives you more privacy to use different addresses. Technically, you can reuse the same address. However, in the example of dinner with friends, any of your friends would be able to see how much the other friend sent you. If you use different addresses, they will have no way of telling. Going back to the tree analogy, the leaves sprout from branches, which represent the derivation paths, the algorithms responsible for generating the key pairs. When you create an account with your HD wallet, you theoretically control all the leaves on all the branches, but typically you only use one branch. To put the same into Bitcoin terms, you only use one derivation path to create multiple addresses that are derived from the public keys. All of these branches converge into the tree's trunk, symbolizing the mnemonic phrase, which is the foundational seed from which all keys are generated. Note that the term mnemonic code, seed phrase, or just seed, are synonyms, and refer to the same concept, which will be explained later. Fortunately, HD wallets automate the management of all this complexity, and in practice it is rather easy to use modern Bitcoin wallets. Expanding the tree analogy, imagine the entirety of potential wallets as a vast forest, stretching across a galaxy-sized expanse with innumerable trees. Within this immense forest, each individual using Bitcoin plants a new tree that is practically impossible for others to ever find. We've outlined the basics of Bitcoin keys, including the operation and security of public and private keys, their generation and management, and the advantages of hierarchical deterministic HD wallets. Understanding these elements is crucial for anyone involved with Bitcoin, as they are the bedrock of security and access within the digital currency landscape.